Throughout this series, we have discovered many unique animals and explored the complex relationships they each share with the planets they inhabit. If you have enjoyed this journey through Galactic Hub space as much as we have, subscribe so you don't miss any of the upcoming releases. In this final episode of Season 2, our expedition takes us to the Dexterf sector of the Euclid Galaxy, to a planet ruled not by plants or animals, but by something else entirely. This is Yoxisrapa, one of 2 paradise planets found within the Oknuts 10 system. It is known locally as Oknuts' second sun, the reason for which only becomes apparent as night draws in. Yoxisrapa supports the largest and most diverse population of bioluminescent fungi so far discovered in the Galactic Hub space. Fungi are neither plant nor animal, and are in fact classified as a life form all of their own. The main body of a fungi organism lies underground, extending in a vast network that runs throughout the planet's soil. This root-like network is called mycelium. The mycelium functions as a courier, transporting both nutrients and information to other areas within the network. The mushrooms dominating Yoxisrapa's grassy surface are all connected to this network and serve as the fruiting body of the organism. The mushrooms release spores into the environment to further the area of growth of the mycelium network below ground. Yoxisrapa supports 13 species of mushroom, and each one has its own special technique when it comes to spreading spores. This is Jamur Grabomeum, a species of mushroom that dominates Yoxisrapa's grasslands. In its infant stages, the mushroom's conical cap is a pale pink. As it matures, the cap transitions to a more vibrant yellow, an indication that it is ready to spore. In this sporing stage, it is called Jamur Coastievis. Unlike other mushrooms, the Jamur mushroom releases spores in a thick tar that drips onto the surrounding soil. The bioluminescence and bright yellow colouring of its cap encourages insects and animals to approach it throughout the night and day. As the creatures brush by, the tar sticks to them, ready to be transported far and wide across the planet's surface. Once the Coastievis has finished sporing, it releases an autodigestive substance that consumes its body, returning nutrients back into the soil. These nutrients are then gathered by the mycelium below and absorbed back into the fungal network. Mushroom spores are incredibly resilient and can remain dormant for thousands of years. Yoxisrapa is home to an incredibly rare species that can only be awoken from its dormant slumber by the chance strike of lightning. This is Tentamerae. This particular specimen, according to botanical analysis, remained dormant for approximately 3,000 years before lightning activated its inert cells. Unlike the Jamur mushrooms, Tentamerae can live for long periods of time and have been recorded to live as long as 100 years. Their spores are released regularly from multiple ovate caps at the top of their stem. The wind carries the spores across the planet, where they wait patiently for lightning to strike. The spores are incredibly resilient and can withstand almost any environmental change. Yet out of all these released on Yoxisrapa, less than 1% would have the chance to grow into the Tentamerae mushroom. Tentamerae, like many of Yoxisrapa's mushrooms, uses bioluminescence to attract creatures that can aid with spreading their spores. But where does this light come from? Within the mycelium network, the molecule luciferin is passed throughout the chain. As the mushrooms absorb this molecule, they draw in oxygen. This causes a reaction, resulting in a soft bioluminescent glow. For the Skinrefoe, however, this is not the case. It is incapable of ingesting luciferin itself, so has developed a clever trick to get a light all of its own. The center of its funnel cap is filled with a sweet nectar favored by one particular species of bioluminescent bacteria. In return for providing the abundance of food, the Skinrefoe benefits from the bacteria's bioluminescence, using it to attract animals that can pass on its spores. Without this bacteria, the mushroom would be much less successful in attracting pollinators, in comparison to its bioluminescent competition. Yoxisrapa's mycelium network does not only pass nutrients to and from its mushrooms. The planet's grasses also hook into this network, exchanging excess sugar for nutrients. The luciferin flowing through the network is absorbed into their cells, giving the grass its fluctuating glow. Another beneficiary of the mycelium network on Yoxisrapa is the humble star bramble. Native only to lush climates, they are most commonly grown via hydroponic systems on an industrial scale. In fact, star bramble farms are a large part of the galaxy's agricultural market, owing to its many uses in crafting and food processing. On Yoxisrapa, star brambles are able to flourish thanks to the abundance of nutrients shared within its vast mycelium network. Star brambles on Yoxisrapa, however, do appear to glow brighter than those grown industrially, thanks to this connection. This increased light allows them to better attract the insects that will pollinate them, allowing them to grow in greater numbers. On Yoxisrapa, plant, animal and fungal life are all connected, each living symbiotically with the other. The beauty of its bioluminescent landscape and gentle weathers is not all that brings interlopers to visit. Yoxisrapa is home to one of the largest archives in the Dexterf sector, containing information on many of the local galaxies and their native inhabitants. Interlopers wishing to visit the archive can do so at these coordinates. We hope you have enjoyed this episode and this season of Interloper's Guide. Remember to like and subscribe and click that notification button so you don't miss the start of Season 3. Thank you for all your support, and as always, have fun, stay safe, and most importantly, be curious.